Have you ever looked up at the moon and wondered about its secrets? For decades, one of the biggest mysteries has been hiding in plain sight, or rather, in the rocks. Samples from the Apollo missions and data from orbiting spacecraft revealed something baffling. Some lunar rocks are strongly magnetic, but here's the catch. The moon today has no global magnetic field. So, how did these rocks get magnetized in the first place? Where did the moon's magnetism come from, and where did it go? A new study might finally have the answer, and it's a story of cosmic violence and incredible physics. You see, the moon isn't like Earth. Our planet has a powerful magnetic field generated by its churning molten core, a process called a dynamo. The moon's core, on the other hand, is tiny and mostly quiet now. Scientists figured that even if it had a weak magnetic field in the distant past, it couldn't possibly have been strong enough to magnetize rocks, especially not the intensely magnetic ones found on the moon's far side. Something just didn't add up. For a while, researchers considered a wild idea. What if giant asteroid impacts created clouds of superheated gas, or plasma, that amplified the sun's magnetic field? But the numbers didn't quite work, and the theory was mostly shelved. Until now, a team from MIT decided to look at the problem from a new angle. They asked a brilliant question. What if the moon once had its own weak magnetic field, and a massive impact temporarily supercharged it? Using powerful computer simulations, the scientists recreated one of the most violent events in lunar history: the formation of the massive Imbrium Basin, that giant circular feature you can see on the moon's near side. The simulation showed that when a colossal asteroid strikes, it instantly vaporizes rock, creating a cloud of ionized gas that expands at incredible speeds. While some of this plasma cloud shoots off into space, a huge portion of it wraps around the moon, converging on the exact opposite side of the impact point. And here's where it gets really interesting. As this plasma blanket squeezed down on the far side of the moon, it compressed the moon's existing, feeble magnetic field lines. For a brief, fiery moment, about 40 minutes, the magnetic field in that one spot became incredibly powerful, amplified by a factor of hundreds, or even 1,000. It was a temporary magnetic storm of epic proportions. But could 40 minutes be enough to permanently magnetize solid rock? It turns out, the answer is yes, thanks to another effect of the impact. A giant collision doesn't just create plasma. It sends powerful seismic shockwaves ripping through the entire moon. These shockwaves travel through the lunar body and focus their energy on the point directly opposite the impact, the same place where the magnetic field was being amplified. This intense shaking essentially jolted the electrons within the minerals of the rocks. For a split second, these electrons were free to move and reorient themselves. So imagine the scene. On the moon's far side, the ground is shaking violently, and at the exact same time, a massively powerful magnetic field is pulsing through the area. The freed-up electrons inside the rocks instantly snapped into alignment with this powerful field. As the shaking stopped and the rocks settled, that magnetic alignment was locked in place, like a permanent fingerprint of that brief, violent event. One scientist beautifully described it as throwing a deck of cards in the air inside a magnetic field. When they land, all the tiny compass needles inside them are pointing in the same direction. And the best part? This theory perfectly matches the evidence. The most strongly magnetic rocks ever detected on the moon are located exactly where the simulation predicts. On the far side, near the South Pole, directly opposite the Imbrium Impact Basin. This incredible alignment between theory and observation is what makes this new idea so compelling. It suggests the moon's magnetism wasn't created by just an ancient dynamo or just an impact, but a powerful combination of both. The even better news is that we'll soon be able to test this theory. NASA's upcoming Artemis missions are planning to send astronauts to the moon's south pole, right into the heart of this magnetic anomaly. If they bring back rocks that show signs of both intense shock from an impact and unusually strong magnetism, it would be the smoking gun we've been looking for. We may be on the verge of finally solving the long-standing mystery of the moon's lost magnetism. Thanks for watching, and if you enjoyed this journey into lunar science, don't forget to like and subscribe for more deep dives into the cosmos.